How to calculate pump head. Have you ever wondered how to ensure your fire pump on a boat operates effectively? Understanding how to calculate pump head is essential for keeping your vessel safe during emergencies. Let's break it down step by step. First, what exactly is pump head? It measures the energy a pump adds to the fluid, expressed as the height in feet or meters that the pump can raise water. This calculation is vital for ensuring that your fire pump provides adequate water pressure and flow to combat fires effectively. To calculate pump head, you need to consider three main components. The first is elevation head. This is the vertical height difference between the pump's discharge point and the pump itself. It tells you how high the water must be lifted. Remember, only the vertical rise matters here, not the length of the pipes. Next, we have friction loss. As water flows through pipes, hoses, valves, and fittings, friction causes pressure loss. This loss depends on several factors, including pipe diameter, length, flow rate, and the roughness of the pipe interior. Calculating friction loss can be tricky, often requiring specialized formulas or friction loss calculators. The third component is pressure head. This is the pressure needed at the discharge point, like at a fire nozzle. To convert pressure into head units, use the relation that 1 pound per square inch equals to 0.31 feet of head. Now, to find the total pump head, simply add these three components together. The formula looks like this. Total pump head equals elevation head plus friction loss plus pressure head. Let's put this into practical terms for boating and fire pump operation. Start by measuring the vertical height from the pump to the highest discharge point for elevation. Next, estimate friction loss by considering the length and diameter of hoses and pipes used in the fire suppression system, including any valves or fittings. Finally, determine the required pressure at the fire nozzle to ensure effective water spray or jet. For example, if the vertical rise is 10 feet, friction loss is calculated as 15 feet, and the required pressure head is 46.2 feet, which is equivalent to 20 pounds per square inch, then the total pump head would be 71.2 feet. This means your pump must deliver water with enough energy to overcome this total head. Additionally, when calculating pump head on boats, consider the suction head or lift. This is the vertical distance from the water source, like a seawater intake, to the pump inlet. It affects the net positive suction head and is critical to avoid cavitation. Also, account for losses due to bends, valves, and other fittings in the suction and discharge lines. Lastly, think about the flow rate needed to supply all fire hoses and nozzles operating at the same time. Understanding how to calculate pump head ensures that your marine fire pump can maintain sufficient pressure and flow during emergency fire procedures on boats, which is vital for safety. So, remember to measure elevation, estimate friction losses, and determine the pressure head required at the nozzle. This way, you can be prepared and confident in your fire pump operation.